screens. Everybody can see us. So this is recorded. Keep your secret ASP.NET things. Well, it's not just recorded, it's streamed. So you're live.
Edit. Hello world.
You are as alive and live as it gets. Don't go to line 10. So let me just go over the feedback from last time. I don't know. Were you here last time? Yeah. Who was here last time? You were here, obviously.
Pablo was here last time.
You were here? No? You were here, Tanner, last time?
I think I called in the company.
Okay, so basically the proposal that can be summarized as in there's two types being proposed. There's a sequence reader of T which wraps the read-only sequence of T, and there was a span reader of T which wraps read-only span of T. Right. The reason that span reader of T can be faster than sequence reader of T is because it has to do extra work when it runs out of the span. The more existing of an extra call can cause the compiler to start stack spill locals, which in turn has regressed some micro benchmark by 80%. The downside of having two types is that the API strip is bifurcates, i.e. some APIs will take sequence reader, some will take span reader, and also the parsing API will have to decide. Supporting both would cause duplication, as you can't funnel them easily through the same call path because there's no abstraction, because they're both, by definition, something we want to keep on the stack as a struct. We could do these things. We can ship a third type that can wrap either a sequence or a span. We can ship two types. One can wrap either a sequence or a span, and one that only wraps span. We can only ship a single type that wraps either a sequence span or ship a span only one later if we discover we need the performance. Yes, none of this will work when you use it from languages that don't support ref structs, which I think we are aware and do not care right now. So there was some feedback on the API, which I think we can skip because it's just the typical naming stuff.
Just some preliminary context again is that like the design by this is driven by two things. One is making it easier to handle the bifurcated buffers that you have with the sequence, which is difficult to write code to that correctly, let alone in a performant way. The other thing is to actually make it hyper performant for and hopefully get to the level of like web type performance, and that actually drives a lot of the compromises in the API searches.
Yep.
In months and months of like doing repeated measurements with this against prototype JSON reader and also micro benchmarks. Even the scope of one single if check will like cause a significant regression.
Yep.
So it's important to keep that in mind. Even adding another argument, we have to really haggle back and forth because like that can cause the JIT to spill things over or not put things in registers, whatever, and like that measures up, and not like 1%, 2% type things. Like in higher level things, it shows up as like 5% regressions or 10 or whatever. So there's a lot of that that goes through with this. I added a second example here. If you want to scroll down. So, well, there's one example now from David's blog post. Well, here's the new example. Okay, so. This is actually based on some of the logic that's going on inside of Kestrel, right? Where we have to break things up by carriage return line feed, but then we're also trying to make sure that we actually have carriage return line feeds and not anything else hanging around. So in doing some prototyping, this made some of the rest of the logic further downstream from this a lot simpler because we can do that sort of double check here in a reasonable, optimized way. So, because these things have been hyper optimized, so the try read to any uses the vectorization where it can, because it's calling the helpers, and it ends up being reasonably performant.
So this thing finds the data that contains the line, but doesn't contain the actual CRLF.
Yes.
Right, header line.
But then we're validating that they're below, and then the rest of the code didn't want the CRLF. It just wanted to know that there's nothing in there, right? That it had a valid CRLF at the end, and it doesn't have another one inside of it. That gets you to that point, right? So we're just try read to any. This is using one of the things to find out, do we have either of those carriage return line feeds, right? We found one, okay. Is it actually CRLF that's next?
Yeah.
If it is, we have these are the hyper-optimized things that we're talking about. Like making a second call actually measures, so that's why we have a lot of this advanced pass stuff, so that you can like make it a single call and not have to get back and tell it to advance. And we're good and we move on. So this is a lot more.
In this situation, Jeremy, what happens if the sequence ends and you're in the middle of something or other? Like, is there a state to be passed back, or it doesn't matter?
If the sequence ends, this one joins it together. So this will concatenate into a span for you by newing up a new array. So I have some proposals for dealing with that. One of them. Yeah, I want to have that conversation after we go through more of the API surface.
Okay. Sorry, I was just referring to this sample function. Like, this would appear to assume that all the headers are in a single sequence.
No, it deals with that. So it will allocate in the rare case that it's cross sequence. So
but the reader isn't returned.
What's that?
The reader isn't returned. So someone calls read header lines, they would presumably need to call it again with another sequence, but there's no state that's passed out of this. I'm trying to understand how that works.
Oh yeah, this doesn't need it because this is a single call. But then in the case of Kestrel, this ends up calling a callback with spans of each header line.
This still needs consumed.
You still have to.
Well, it
return a position.
It returns out consumed. I simplified the example to get rid of that.
Okay.
So so it will say how far it actually read, and you can get that out of the reader.
So you said so try read to any takes the first argument is the output, and then the second argument is the delimiters.
Yes.
Okay. And advanced pass delimiter means skip the CRLF and return the line, and then is next checks my current position to see if the next n characters match the span.
And that's
I see. Yeah, that's clear then. Okay,
is it matching like one of the elements of the span, or like
the
whole sequence?
The is next that's a sequence, right? So it's making sure that that sequence is next.
Okay.
The other one, try read to any, that's the any part of it. It says like either of them are there.
CR or LF.
Yeah.
Yep.
It just so happens that like you can use the same span in this case. And this is a pretty common sort of thing people want to do, is like break things up by CRLF. And you can just do that straight up, and then there's also the ability to like check to see that you actually had anything else. So there's try read too that actually takes a sequence too as well if you don't care about like dangling CRLFs, and like you don't have to do a two-step.
Yeah.
But this is still fairly optimized.
Yeah, I get it.
So anyway, and there are some questions, like there is an assumption here that like in the normal case people don't really care so much about allocations or that cross segment boundaries and sequences, since it should in theory be a relatively rare occurrence. Now we have ways to address that, and I want to discuss that after we look at more of the API surface again, just so that we don't get rattled into that without context of how that fits into the existing API surface.
So if that's true though, like isn't then the argument that the amount of perf we have to track would only be something that would be ideally very rare? Like so if you wrap a read-only sequence versus a read-only span, if we assert that the buffers you get passed in are usually large enough that running out of the span or running out of the sequence in order to go to the next one is rare, then why would that make a huge difference?
A huge difference in which part?
So when you have a reader that just deals with span versus you have a reader that deals with read-only sequence, right? The moment when you cross the boundary from one to the other, like the span one would basically return and say, I need another span. I ran out of this one. In the read-only sequence case, you would just call the method that basically gives you the next element in it. But that is rare enough. So should that also be the performance implication of this case be rare enough?
It's the performance it is certainly designed around like hyper optimizing everything being in the current span. So the issue about overloading the other thing, there's also an API surface problem. Like there are things here that return read-only sequence for good reason. those things would have no meaning in a span-based reader.
And a position.
But addition to which, position stuff is also awkward. You can lie and like do weird things, but like that makes me sort of feel dirty.
Sorry, keep going. I thought you were done.
So in any case, like getting back to the original point, like that one extra check makes a difference, and a significant difference, and that was part of what I called out before. So that one extra check that ends up being a no-op in the case of things that are a single segment kills you when you're talking about working with spans.
But that's the thing I don't quite understand. Like this extra check you're talking about. Like, I mean, whether you have a span or a sequence, you still have to check whether you ran out of space.
Well, sure, yes. So like you're taking a hit for that. But if you write one that's specifically for span, it's way faster to take out these extra checks. I mean, like doing binary reading and stuff like that. It's like these things they're all very potentially very fast operations.
So maybe my naive model is wrong, but like the way I think about this is that when you're on the reader, it has a field somewhere that is my current span, right? And so when you initialize it from a span, it sets that. If you initialize it from a sequence, it extracts the first span and puts it there, right? So all your operations normally just deal with that span. Now, when you actually hit the case where, oh shit, I'm running out of space on that span, that's when the extra work would kick in for a sequence versus span case, right?
Yeah. So
but that would be a rare case then, right?
Yeah, so the sequence one won't be any slower to add support for span. It's the span thing that's much slower than it could be. So, like, if you write a reader specifically for span, and I did this and ran the test, and that's part of the other pieces that came into this, it is in some cases like 60% slower, just that extra check. That's a no-op, right? To remove it completely, you get a 60% improvement in performance.
Yeah, but maybe like I'm getting it. Like, but what is the extra check? Isn't the check effectively like if position is less than span dot length for the most part?
So the extra check is at the end is like you couldn't find it.
Yep.
Go get the next span, which is a no-op if you have no more spans left, and we have that optimized. So like, but like that.
So just saying the fact that the check exists in the method body, that was the whole stack splitting locals thing, I guess.
Yeah.
I see. So the code gen is just unfortunate in that case.
Yeah.
So the other thing with having a common type is consumer of this type doesn't know when they can use position or like anything sequence related. Because if they do, what happens when you pass in span? Does it throw? Like
that would kill performance. So we'd have to like let it just kind of barf.
So like from the outside, when you see this API that takes common reader or common reader of span or read-only span, if the parser doesn't happen to use sequence-related APIs, you can pass both span or sequence in. But in case parser decides to use sequence-related APIs, you can only pass sequences in, because for spans, they don't have alternatives, and we don't have overloads. Like, if you want to slice a read-only sequence out, you can only allocate, and it's not really an alternative.
I keep coming back to if we even, and I know people are going to not like this, but I keep coming back to whether we even want a buffer reader for a read-only sequence, and here's why. We know we could, I know, but we know we can get the one that's just for span really fast. We know there's a higher level bit of code around using the buffer reader, regardless of whether it takes a sequence or a span for working with pipelines, right? There's a higher level thing about getting the next sequence from the pipeline and then passing that into the reader. And so there's already boilerplate at that level. If you move the sequence related boilerplate out of buffer reader into that level, you kind of coalesce it with the other boilerplate that's already there. You keep the buffer reader really, really, really fast, as optimized as it can, and the overheads associated with both going back to the pipeline to get more and kind of updating your sequence seems like the overheads there kind of merge together, and you end up with something that's not that much more code and that's faster. And this seems to also kind of gel with what Austin was seeing with JSON Reader.
The different overheads. There is I'm out of the entire sequence, so get more from the pipe. And there's I'm out of the current span, move to the next span. Both may be kind of rare, but I think we need to write the boilerplate code that does the end-to-end, see how bad it is. I'm fine like having a span reader only, if we also write the boilerplate code that everyone would have to write to get new data.
I agree with you. If I'm wrong, if it's like horrible, like it totally makes sense, right? But in my mind, and maybe I have overconfidence in us, and in my mind, the boilerplate's not that much worse than the boilerplate you already have to write.
It's
pretty bad.
I could be wrong, but.
Well, it's actually pretty bad.
Yeah.
Like it's if all you think about is like you're only going to cross a boundary once, it's maybe not so bad, right? But there's no guarantee that that's the case. And like you can cross 3, you can cross 4. What happens if you have like hundreds of megabytes worth of data? Right.
Or more than 4 gigabytes like ML.NET has, and they want something that can work with, over in 32 max value length.
Yeah, so this thing is long.
I'm not understanding why the size of the span matters.
Because a read-only sequence can be longer than int32.
Sure.
Can be a long.
Right.
And so if you have a buffer that works with it, then you don't have to write all the boilerplate.
If someone's chunking their input up into 2 gigabyte pieces, like the overhead of calling into the buffer reader to process 2 gigabytes compared to process 4 gigabytes, like that doesn't matter.
It does matter if you're like actually going to then pipe this thing down through to like another read-only sequence. So
or
that's
if you're
entire
the GPU or doing vectorized algorithms on it. Oftentimes it's faster to have one process read in the 2 gigabytes and buffer it into memory because you have that space, then operate it while you have another thread go and process into the secondary buffer.
Okay, I think we're in the weeds. I don't understand at all how that impacts this. So someone should write this before we decide to ship either a reader that operates on read-only sequence or either exclusively or in conjunction with span. I think it's really important to see what these cases look like in both ways. So that we can make a valid choice. That's all I'm saying.
Yeah, like I think we need to incorporate the feedback from Christoph there, and like because I feel like I'm more or less in that boat as well, where I understand that you want to optimize this thing for performance. At the same time, though, the cost of having 2 types floating around and let everybody make a choice might make it worse because you now have to effectively do some crazy gymnastics to adapt one to the other in order to use the API.
The only thing I'm seeing
is
but
that... to Pavel's point, the API that works with both also has its downfalls just from a usability perspective.
Yeah. The only thing I'm hearing is that you want 2 types because it can't be one. Because writing the code to copy the buffer, copy the remaining buffer from the previous buffer into a new one and to append to the sequence is kind of the entire point of this type, right? The type is to start from doing that. And
and that's exactly what I'm trying to get at is like this, like there is a scenario where like you just want it to be simple, you want spans out and you don't like, and you want to be able to just deal with spans, but there are also more complicated scenarios where you're going to like then I want another sequence, it may actually be crossing 3 other sequences and then I want to pass that thing on again and then split that thing up again, and like you can't do that unless you actually continue to use the sequence model. So
I mean my argument would be like, I mean, it was just one option to have one type doing both, but the other option that we have is we only have one type and then we pick the sequence for that and say everybody who really wants the last performance, you write the code. I mean, like you want to deal with spans yourself, you want to get the last mile of performance out of it. Well, that's why we have low-level parsing APIs that just operate in spans.
And that was my kind of preliminary argument. I don't really see people actually using span reader, right? Because like in most cases, the data that you're starting with is going to either be something like sequence, or it's going to be an array, something that you can wrap in memory that you can then wrap in a sequence, right? If you want to be using this thing for those things, that's like stream reading of some sort. You're not going to be starting with a span.
Reading an array is pretty easy.
Yeah.
Like people know how to enumerate through an array that has an indexer throughout and like do each character equals this and like
so like
the hard part in sequence reader is that there is no throughout indexing. Like if read-only sequence had indexer that was free, we might not need this type at all. But the problem is that you cross segments and you need to keep track of your position and where you are and this and that. So
like my real proposal here is not really that we create a span reader. It's just that that is the option if we find that people actually want it. My gut feel is that people will not want that. Because like if you're at the point of having a span already, we already have all. It's really nothing more than a convenience thing that slices for you. Right?
Yes.
So that's like
the main thing is that it will slice for you. I think the complaints I've seen is where people want to use try read, big endian int or whatever, and they have to do slice for after calling that, and it means you have to pass the span by ref if you're passing it to helpers because the span gets mutated. And that's kind of what people want this type. Brands, but it's not.
So I'm happy to be convinced. I would just love to see the following. I'd love to see, like, take this read header lines example. I'd love to see what this looks like with using it, like only using the span constructor as part of a larger loop that operates on a pipeline.
We have it. So we have it, right? We can just copy the code from Castro. Like Castro does it today.
Yeah, well,
Castro has the
but like, just make it. I'm just asking if we're trying to compare. We're trying to look at usability and perf. So for each of these things, I'd like to understand what the usability, like what the code looks like, and what the perf is for side by side. If you just have your outer, you're using pipelines with a buffer reader optimized for span, doesn't work with sequence, compared to you're using pipelines with a buffer reader that supports sequence.
So
and, if it comes, sorry.
Go ahead,
Jeremy.
I thought you were done.
I was just going to say, and we look at those two things. Like, I believe what I'm hearing is that the first one I described is going to be more unusable than the perf wins it provides. And if that's true, then okay, ship the single buffer reader that supports sequence and span, and and we'll deal with the rest of the fallout. If that's not, if my theory is right that it yields better perf and not as bad as we think usability, then maybe that's something we should really consider. But I could be totally wrong. It may be horrible usability and not that much better perf, and everyone throws bad fruit at me.
So I did. There's a copy of the Kestrel code that's in CoreFX Lab, and I have a change that actually converted it over from using ByteStar to span. And this chunk of code here, now I gave up something for like moving from ByteStar to span because there's no way to make that equivalent. You can get close, but you can't get equivalent. It's just the nature of the beast. But I made it as fast by taking advantage of this. And like, I know you really know what Kestrel looks like, and you know where this fits in here. But like, these things have actually made it's way simpler.
Nice.
There's a lot of logic in here that's trying to like do the stuff between it's multiple segment, it was this thing, and like we're gonna pass part of the carriage return line feed stuff. We'll stop at line feed, and then the rest of the stuff is trying to look at it. That's where I got the stuff back from.
Yeah,
this.
I know because we spent the entire 2.0 release, half of it, trying to write a fast parser, like about 5 different devs on their own. And we ended up with what we have today, and it's super fast. And the best way to do it was to drain the span, and then when you cross segments, use the reader, right? And the hope is that the reader can, you trade off some performance because it won't be as fast as that, but at least it'll be fast enough and readable. So you kind of are in the middle.
So it's much more readable now. I mean, like, again, if we still went back to pointers and followed the same sort of pattern, it would still be faster. And but like you can't. You can do really well with this, and I'll share what that looks like. I'll actually make the PR. Actually, I have the PR for it. I'll share what the PR is for it.
Yeah.
There was just some argument about whether or not I actually like put it in or not.
So one thing that I was explaining was building a reader like for JSON on top of a span-based reader. Why can't we do the same approach here? We have the buffer reader that's based on span, and build a sequence reader on top of the span reader.
Because it's slower.
The sequence reader is slower?
You're adding another layer on top. I mean, you saw this in your own measurements, right? Like every single call matters.
In my measurement, the sequence reader actually got faster. The sequence reader based, like JSON reader, read-only sequence based JSON reader got faster if I'm leveraging the span based implementation.
No, the calls that you made to the buffer reader, right? Every call that you make another call just to advance, like it hurt your performance in a significant way. Now,
He's saying his
imagine-
performance, but Ozan, aren't you saying that it actually improves your performance?
Yeah. So if I'm not using if we separate JSON reader and buffer reader, in the JSON reader case, the exercise was, can we build something that's span based, and then build the read-only sequence based on top? That's what I'm trying to extract out.
Yeah, and I
Right?
got that. That's what I was just saying. Like your calling of the existing buffer reader, you made one extra call, it tanked your performance numbers. That's why we have these advanced 2 and advanced pass stuff, right? And specifically for consideration with your stuff. Now, the same thing would happen if you're wrapped around another thing. Is that like we're then adding another level of indirection where we have to make another call where the JIT can't like collapse things in the same way, and like you're just going to take another 5-10% or worse performance hit. So, because the measurements we're really trying to measure, and I was really optimizing for the single segment case, and then also measuring for the cross segment to make sure I did that okay. But like, I have the micro benchmarks for each of those things.
The way I was thinking, like, those calls would not exist anymore because all your operations are on span based. So the extra calls like advanced 2 over and over again will drop down to only when you actually need to cross boundaries. If you are wrapping a sequence-based reader on top of the span-based reader.
Well, the presumption is that like you don't want something that then passes out sequences, and I don't think that that's what we want. So that's one of my fundamental arguments is like you need something that still passes. You need to be able to still parse into another read-only sequence.
Yeah.
It's like I want to try read to, and due to the scenario that I have, I know that I still don't need to. I don't need to spanify the whole thing.
Yeah.
I'm going to be grabbing out in a smaller chunk, which is going to be less likely to be crossing boundaries because I'm looking at this, or where I just need to know some extra data and some other parser that's going to get this read-only sequence that's going to then wrap its own buffer reader around it or do whatever it needs to do. Like once you start basing everything on span, you're done. You can't do that.
It's a leaf node.
Yeah, like
Then somebody writes
the entire
another one
goal
of
of
these things.
read-only sequence reader is to get to the size of the span where it's very likely is not crossing anything.
Yeah.
Like that's the entire goal.
Or you pay for a copy at that point. So you have a giant line and you split into some segments, and then you find the thing that is small enough that you don't mind allocating, turn into a span, and then you parse that thing into a primitive, and then you move on. And the other big part is keeping track of the position is important. Knowing where you left off, so you don't have to rescan the buffer after you finish, is important for the pipe scenario. So you parse the buffer, and then you're like halfway down, and you yield from the parser. The pipe can just say advance from there, and it doesn't have to rewalk the buffer from where it started from. So keeping track of where you were when you ended parsing is what is nice about this thing too.
And we're hyper optimized for giving you that position. Matter of fact, there's a proposal in here to add an unsafe get position to make it even faster. Because like in the reader, we know we're in a segment.
Yeah.
And we're
Exactly.
like, it's just offset this thing. So like I added that down here, and you'll see.
What is the
that
position going to be? Is it like the position in the current span, or the span, or is it like the global position?
So like the sequence position is an object in an int, and like there's in the case of the read-only sequence, there's a flag that's set on there that's kind of an internal detail, but like it ends up it's like significantly faster. While we've done a good job of optimizing, trying to get position and to look to see, oh, is it in this segment or not? Like all those extra checks and going through a couple different methods adds a significant performance hit to keeping track of position here, because we've already done all that.
I kind of not
So
that much into the. My question was mostly like, is the position like the global position?
You have
like-
this,
Yeah.
it is. You have this
Okay.
list of arrays,
Mhm.
and you end up a position is a coordinate like into a specific segment index. So you know
and it's
the link
from
and
the beginning essentially.
from,
right?
yeah from there.
Okay.
This is a nice sequence.
Okay, that was my question. Alright, sorry.
This is a segment.
Yep. Okay. I got it. I got it.
Yeah.
Thank you.
So, anyway, can we go down and look at those sequence APIs to give some context of this?
I'll say one more thing about
Sure.
the crossing boundaries. Even though it is rare, the way pipelines works is that the buffer is kept around. So for example, you're in from the socket, and you don't want to pass in a one byte buffer. So imagine you had a 4K buffer, and you used up all but 1 byte. You wouldn't use the last byte to pass the read. You would allocate a new buffer, move on, right? So we end up crossing boundaries more than you think because we don't want to drain the entire buffer for perf reasons, right? You never want to pass less than some minimum amount of data to the actual thing. So if you didn't use up the entire buffer from the last read, you may end up passing, a bunch of data from the last segment and a new segment to a parsing API.
So why would that increase
But
the
doesn't, David, I understand that. That makes sense to me. But at the same time, doesn't that also, in effect, sort of often mean you're going to have at least some minimum amount of data that you are passing to the buffer readers, is some number of thousands of bytes or whatever, so that there actually be a lot of processing that happens before you get to a sequence boundary?
It depends, right? So like this, it isn't for a specific request. That may end up being if a request is big and you don't end up parsing the entire thing, you may end up passing the end of the previous buffer because you may not have had the entire thing in a single segment. So you may end up allocating more data in a second segment, even though you still have a valid request in the previous segment. Does that make sense?
So if let's say you're saying you have two requests and the first request ends at the partial request ends at the one less buffer than the end of it.
Right.
And then you have a second request.
Right. We won't just allocate a new one just because we still will use the old buffer if it has room, if it has enough room. So you may end up crossing even though you could do better if you made a new array that had the entire thing in the first place.
I understand that.
Yeah.
I understand that there would be ways to optimize for the number of buffers, but I'm saying it seems like with this approach, you're also optimizing to minimize. You're still sort of guaranteeing, by some definition of guarantee, some minimum amount of data that will be in each span.
Yes. Yeah. Yeah.
How does that increase the frequency of stragglers?
Like, not every request starts from the
zero.
From the full segment, from the full memory block.
In theory, right? If we were to return the array every time we consume the entire request, you start fresh with a new array every time.
I see.
So you would start from 0 and go up until n.
Yeah.
But we just start where we left off from the previous request. So you may end up using an old block, even though you would have had a single block if you had made a new array in the first place.
That makes total sense to me. But
I get it.
Let's say your threshold was even like, half the size of the buffer. If half the buffer isn't remaining, you're going to go to a new one. Yeah. If your buffers are 4K, that's still 2K worth of data you're passing in a span.
Sure. And cookies are 4K. So that's one header. All right.
Sure.
Our job tokens which are ginormous.
But the amount of work processing, 2,000 bytes and then making another call and processing 2,000 bytes. Maybe I'm wrong about the cost here, but the processing of the 2,000 bytes would seem to dwarf the size of the extra call in that case back to process the next span.
Yeah, in my case, it's amortized to like less than 5-10%.
Okay, put it this way: if I run plain text, and I didn't have the code to optimize for parsing a span at a time, and I just wrote the code to assume that you could split every time, is that what you're saying?
I'm not sure.
Are you saying that the perf hit you take on the buffer switch is minimal because it's rarer than the actual parsing of the buffer before it? That when you jump
that
buffers,
that was my question. Is that true? I'm not sure if you're saying yes or no.
I'm saying that the perf hit is tiny if you do parse a span up until a switch. Yes, that's true. And that's what this is optimized for, I think, right?
Yes.
It does that.
And
right.
It takes away, it is very, very difficult. I mean, like, again, we can write something on top of it as well, but like, getting back to the other point, is that like, this is also optimized to do as little spanifying as possible, right? To narrow it down to the specific scenarios you're doing.
Until you want it.
Yeah, so like, if you're saying that like, we have to like, copy, copying becomes like almost mandatory for things, and like you have to like, how do you find the next?
Right.
For example,
what,
if you're crossing.
We've already spent 40 minutes on appeasing me, so we can move on. I'm not sure that my request has been heard or that I've voiced it correctly. So let me write down what I would love to see, and we can go from there and move on here. Does that sound reasonable?
Sure.
Yeah.
Great.
So Emo APIs.
Yeah, let's look at APIs. Probably a good thing.
Make sure you can find my mouse cursor again.
So we'll talk about this, the allocator thing.
Allocator.
Yeah. Well, let's talk about the other. It's not.
Oh,
It's not a
I get it.
This is for the if you're crossing boundaries
Yep.
thing. If you don't want it to just
Interesting.
do it, and I'll explain how that works. But I want to actually, with all these things, I think it really helps to see what the surface area is of like what these APIs are, and then you can get some more context. So we changed some names. You know, we have the end thing that tells you no more data is going to overlap. Like this is one that was a little tricky. You know, not really sure the best way to do this, to name it. But you can do some pretty good optimizations on the user end of it if you know there's no more data coming. Right. So you are in the last segment that you can sometimes utilize that.
That helps for like encoding and decoding possibly the encoder APIs, the convert APIs.
Yeah.
So
So
you say is last segment.
So you can like you can do some hyper optimizations on the other side of it. It's like, well, I don't even need to bother because I know I'm in the last segment. I have this much data left. I know I need to go back to the pipe and ask for more, right? Before going and trying to
get more data.
Yeah.
So one question I had was around the concept of is final block. So the sequence reader never accepts concept of is final block. So let's say you have a read-only sequence that ends in a number 1, 2, 3, but the pipe has more data. It's possible the number is 1, 2, 3, 4.
Yes.
But you will return 1, 2, 3 and say that's it, I'm done.
Yeah, but the reader is limited to what
I can see.
to read-only sequence that got passed in. So it doesn't matter how much pipe. Like it depends on the logic. It depends on
Yeah,
how
it
that is
assumes
implemented.
that it ends at 1, 2, 3 and that's it. But it's possible for the pipe, like for you to go back to the pipe and get a new sequence that has the next remainder of the digits.
Correct.
What would
Yeah,
the parsing
but-
logic look like there?
But this reader only operates on read-only sequence that got passed in.
Right.
So it doesn't matter what's inside the pipe. It ends
So
where the
my question,
read-only sequence is.
right? So my question is, what happens if you have a read-only sequence that has 1, 2, 3, and the pipe has a data that's 1, 2, 3, 4, and you say read, give me the next digit, and you got 1, 2, 3.
As it stands right now, it won't work. It doesn't work for like the binary. Well, the parsing doesn't work like that.
Right. So what?
We can change that, but like, why don't we get down to
Okay.
those APIs first, and we'll talk about those ones in particular, because there's a lot of caveats that you have for that, given that you do not know where the end is, right? So like the other option for this one, as opposed to saying like Atlas segment, the only reason I thought about like doing it as a specific helper is because really what you're looking for is next segment get object equals null, right?
No.
So.
Yeah,
It's not the right logic to use. Because there might be another next segment.
Yeah.
Huh?
So you can read-only sequence may represent this area,
Sure.
and this won't be null.
Could be empty.
Okay.
Right, you're checking next segment, so this is next segment.
No, but that particular read-only sequence next segment would be null, right?
No, like it can be 1,000 segments
Yeah, but why-
after the read-only sequence.
Sure, but the read-only sequence you got, its next segment should remain null. I know the original one doesn't have.
No,
so
read-only sequence is 2 positions, and the end position next segment
Oh,
can be not null.
okay.
It's just the end position is where you stop,
I see.
no matter what's after it. And you should never look. You should never even look past
But you could.
what's after it. No, because that.
Well, no, you shouldn't. but, like,
So is it like-
So I
Is
think
this-
the answer here is that like we do need to make a helper method for that, so that like people know that there's another. Like the thing I was looking at was that like you have the ability to know that calling next, right, is not going to get you anything.
Yeah, but that should be implemented as current segment. Get.
So
How would you
like,
do
but that's what this thing is
Yeah.
trying to do. So like we can iterate on
Yeah,
that.
but
so like
just don't implement it like this.
yeah, so well sure.
Wait, then how would the
So, like,
enumerator work? The read-only sequence
Well,
enumerator.
let's
does it
go
work?
So
to
we
the
don't
main-
want to.
let's go to the main APIs
We had
sometime.
the advance and rewind. We talked about that last time and changed those things on that. That's very important and useful. And like it's hyper optimized, of course, for like if it's in a code span, and not to think about that. Scans from the front if it has to. If you But the normal case is that you're actually just going to be relying a few bits, and they're more than likely going to be in the current span. So like it does the checks to see that it'll fit, and it just changes state.
Yeah.
Consumed, of course, is just how far you've
So,
gone.
like, if you're rewinding by few bytes only, and that's the expected scenario, why not take int or short or something? If the basic scenario is to rewind only by few bytes, and you,
But you could still rewind by lots.
but you can
Oh,
still
really?
go back to the previous span. Because like it feels to me like the read-only sequence.
So you can
sequence
still
should
go
like
back to the
give
previous.
you
You
the.
can go back to the previous band, and again, it's a performance related thing.
Okay.
Your like advance has to be as fast as
Okay.
possible.
What if your sequence reader is like kind of continuously reading the data and you can never come back? Like, is this like kind of covered?
Well, when you have a read-only sequence, you can always go back. It's when you go back to the pipe again and ask for another read-only sequence.
I see.
Then you're in a different world. So,
I thought of this like the current one is the read-only and the previous.
so
and
the other
next
way
one
to
is
keep track of things is to actually keep a copy of the reader, and that keeps your index. But like, yeah, it's totally random access in the in the read-only sequence that you have until you said that you've move forward to the thing that gave you the read-only sequence to begin with. Then you have to get a whole other read-only sequence, and don't you dare play with it. I'm sure you got. So the current span and the current span index and the unread span is just basically a helper for that just puts the two together.
Yep.
And there's a cost to that, of course, because it slices the
Slice
cost.
every time.
And then the sequence position is the actual position, sequence position thing, and I have a proposal down there that I'm unsaved so we can do that efficiently. And then the original read-only sequence, you can get at that since we have to hold that in. So we go down to the actual things that do the parsing here, and we change the names and it's based on feedback from last week.
It's try peak.
Yep. So there's try read and try peek. Right? And we went past all the peek. But so there are try read and try peek are pretty straightforward. That's just what's next and get me what's next and move forward. Both things. And
What is peak?
So
Return a span and take in a span.
This one's the more complicated one because, like, again, it's optimized for being super fast, right? And there's no need to copy in most cases. So it just slices and gives you back. So like that copy buffer is like, if you have to copy into this, right? So we use it all the time internally, like when you're doing binary parsing,
You
for
pick
example.
4 to find the actual int.
We look to see if we have enough space in the current span because we do the current super high problem. The slow path is like, okay, we'll stack alloc in this other method,
Then peek into
then peek into that. Because it's only we do the same thing for parsing because we've limited it to 228 bytes. So
How do you fix that?
That copy only happens when you cross between segments.
correct.
Yes.
How do we? Okay, that. I love what it does. That API is super hard to understand.
It is very hard to
How do you
understand. So like I'm like that one I'm willing to like
What
continue
language?
or happy. I mean that's I'm always willing.
What would indicate? So, brainstorming. What would indicate that the copy, the thing you passed in?
Why do you need an indicator?
I actually don't need to know.
I-
So you only call. Okay. You only call that.
my XML comments for this are very verbose. The other thing to do is like potentially put
You
like
stack a lock, you pass the buffer in, and then you never use it again. You use whatever got returned from this method.
Right, you're basically passing in scratch space that you can't touch again.
maybe
until you're
I
done
can
with the
maybe I
span
can call it
return.
that scratch buffer or something.
So it may not get used to. You may have wasted the stack allocation, right?
Yeah.
That's
Correct.
that's the biggest downside.
Yep.
So you could
But you never
you can
know
make it a
before.
func, but then it won't work. You can make it a span action, but then you're taking a hit to passing a delegate to.
Yep.
Yeah.
Just use it for small buffers. Like don't use it for large ones.
Yeah, that's
For large one,
that's
introduce
very
a
it's
few.
very it's what it's intended for, and it is what it's used for. It's like these small scenarios where you run over and you just want to grab it. And
It's
parse it.
nice.
Jeremy, what does this do if the copy buffer is insufficiently large?
This also tells you that it's at the end because what it passes, like if you basically the copy buffer is also telling you how much data you want, and if it can't fill it, it slices it. So we use this logic internally as well. So like again, you're parsing an int or doubles a bigger range. Like and you get back, you say like, well,
interesting. So that means so if I want to peak, let's say it's got it's operating on span and it's got 100 T's in the span, and I want to peek into that to get 100. I actually have to pass in a span of 100 T's in order to get back a read-only span to the existing buffer that already has the space
for this one. And it's a convenience thing. I mean, you could build all this stuff yourself. It's just like this whole thing of moving forward without allocating or is actually or changing the position and keeping track of the existing position. There's quite a bit of logic in there to do that, to spin forward.
The only thing I can think of is like doing a func.
And we have other matching things in here, like this. That's the other.
Wait, how would func work? You need a stack space in the calling method before you even call this.
You can't even return it. You have to stack out upside.
You have to stack out before.
So it is truly the most awkward API we have in this, but it is actually used a ton.
It's useful.
It's super useful. It's very hard to like express precisely. I mean, without putting like 30 character long.
What's a good number for the biggest size of this file you should pass in here before it gets like expensive?
Well, you shouldn't be doing anything more than like 128. That's kind of what we were.
Why is the return read only?
And that's also another thing. Like that just got approved.
Because you misslice, right? You misslice the current.
Because you can't pass in.
Because read-only sequence is read-only.
Yeah. So the read-only.
No,
Because I think this is the span for the input, right?
Huh?
This is the read-only span, which is kind of a view on the copy buffer.
I meant the read-only keyword.
The read-only.
But it may not be on the copy buffer. It may be on the underlying data.
Exactly.
So
yeah.
like the read-only keyword is new. It's not even like really done yet. It just got approved.
Oh shit.
This is the. It went through design review this week for language design review, whatever. Like, it's one of the pending things. One of the problems we have right now is that like you cannot express immutability, and the current checks can't know that. So like if you stack alloc, you can't use the nice, convenient, no unsafe syntax. You can now with this if you use the read only, but you can't change state. There's also another one. So this says that like we can't modify this, which we don't need to in this case. So that's why I've added it here, just kind of really call that out. And I have a section down below explaining that, and also explaining where we're still missing it. So the other places that actually take a span, where we actually have to move the state, you're still stuck in that case. And there's a proposal that's bubbling around in the background to like have a no capture keyword or something along those lines that allows you to say so like if you pass in a span, you can attribute that thing. Terminology can change, and probably will, but like the no capture would basically prevent you from capturing it, allow it to say like, oh, sure, go ahead and pass the span in, even though you're passing it to this thing that's a ref, it's not going to hold on to the span, so I don't have to warn you about it or do anything. You don't have to slip into unsafe territory.
It's Rust. Awesome.
Jeremy, I know it would be you put it on the APIs that don't mutate and that take a span, but presumably you would also put it on methods like try-peek, right?
No, because try-peek doesn't take a span.
I know, but it's still immutable, and you still would want to call that from an API design perspective. You'd still want to call out that it's not mutating this to the caller, since we have that ability, right?
Sure, if that, sure. I just put it where it was actually a problem. But yes, like if we can add it there, we should. It's fresh off the presses, but like I was addressing a specific problem that's listed in the problem section. It's really hard to use this because you have to do it. Well, it's not hard, but you have to do this the unsafe to do it. And it would be nice to get out of that because it's kind of the whole point. And those things are in progress. It's partially there. There's another solution that fixes the problem. So we changed the terminology on the advanced stuff. So we looked at the is next stuff and are any next. This was.
Are any next?
Yeah.
Who approved that name?
Huh?
Who approved that name? That emo?
Which one?
Are any next?
No, I think we had feedback on this last time. So.
Advanced pass is fine. That one reads better. Are any next feels like it's hard to.
Got any suggestions?
Mistaken.
I think feedback from last time was because the names were all over the place was to actually use advanced everywhere.
And we did.
Isn't any singular?
Huh?
Isn't the word any a singular? Shouldn't it be is any next?
Is any?
Yeah.
I think it's our any.
Are any of these choices applicable versus is any of these choices applicable? I think it can be either.
Oh,
English.
How about our is any next?
maybe just any next.
Just have both, and then we can choose.
Any of.
Any next?
It's a very Java style. If you're any of. No.
More like Lisp.
We use is everywhere, so.
Yeah,
For
it
Boolean
is
properties.
yeah, but like
Is next seems fine. Is next.
well, this is a Boolean as well. I mean, I don't mind putting is any next.
Is
But it
next.
sounds
Any
Is
wrong.
next. Is next.
Why not just is next?
Is any of. Is
And
any of.
overload is next.
Maybe
Because
one
then
off.
you don't like
One
any-
off maybe.
The any next.
because then you're rubbing up against the other is next, right? Like
Honestly,
there's a
this-
difference in like is next can like if you pass in multiple things, is next is like that's a sequence.
Maybe one
That's an
off.
and versus an or, right? The
What
any
what
is-
about one off?
So like the any is
One of.
or yes.
Any is from link, right? It's any or when any, where you doing either or.
One off sounds like one off any. So. 'cause you
Honestly, I would just go with is next any. Because then they're all in the same bucket.
Is next any.
That's what we have for like index of any, right?
Yeah.
That falls into the same.
Oh, you do.
So is
Index
next
of any. Index of any. That one actually sounds good though. This one. Index.
One of any maybe. No one of. I don't know.
Well, it's index of and
I like
index
any. I like of
right?
any. As a
I would just.
is
strip
of
it
any. Is any.
I would
Is
just say
any. Is any is actually nice.
Yeah, I think is any is good enough.
Is the nextness?
So is next
is the
any, right?
nextness? Is the
This
next?
one is hard
I
to
like
name.
I like is next any, but that's
Yeah,
just-
is next any probably sounds better.
Yeah, the next thing is important to me. 'Cause
Yeah.
it, like tells you what.
I think
I like
last
that both
time-
because it rolls off my tongue and it matches index of and index of any.
Yeah.
So
I like
is
yeah,
next
I like
is
is next any.
Is next any.
Yeah.
All right.
What is it?
It's also a subset of is next. Is the next one any of these? So is next.
Yeah.
I think last time the feedback was also like is next was weird. People suggested starts with.
Sounds good.
In which
too.
case it would be starts with any.
But
Right.
starts with
It starts
advanced
with-
past. sounds
My
kind of
concern with
weird.
starts with on a reader is I don't know whether that's referring to the present position or the initial position I passed in.
That was why I didn't go with it. But
Do we have any other readers that do this? We don't, right? This is new. We don't have anything in the VC that reads that moves its position.
We don't have readers like tokenizing scanning readers.
Oh, like
this
Java.
at all.
No.
Java has
This-
scan next.
Yeah, this
What about
is
just next?
this is quite new. I mean, this like
No.
it's taking hints from binary reader and text reader, but like it isn't those
Oh yes, yeah.
either.
There's very different. Yeah, those are very different.
Yeah, they're just consuming and giving you something. They never.
Text reader has peek and
Yeah.
read, but there's nothing like checking the current spot for.
Yep.
For, yeah, this is new.
But super important when we're talking about like
Yes.
keeping position and
Yeah.
stuff. So, and as we iterated, we constantly use these, right?
I imagine Roslyn has this.
Well, even in my
In their-
example, even
in
in my
their
example,
token.
we showed it, right? You know, like
They don't expose it to you.
I know, but they must have similar like.
XML reader has is start element.
From where I currently am, that's similar.
so,
I bet you it's called something like look ahead.
In the brush for Roslyn. It's probably peek.
I'm happy with is next any because like again that groups them together and
Yeah.
we can continue to iterate on these if like
Advanced
people
pass,
brainstorm some
advanced
more.
passing. I like
Yeah, let's focus on the functionality first.
So actually
That's
starts
easy.
with
That's too easy.
matches is
Names are
starts
easier to miss.
for XML reader, and it has the same problem. It's not doing from the start of the underlying buffer. It's from where you are current today.
Yeah, and I agree with Stephen on this that it like for me I have I have to go look at the documentation. I have to because like well, what do you mean? It starts with sequence
Where?
or what starts with right? Because I would have to read it
Okay.
to know. This it's kind of is any next, like, well, this definitely involves the code position, right? You know, so at least.
Well, they call it peak token, and
I
they
see.
allow you to pass in an offset.
Yep.
I have a question about these optional advanced paths. So you talked earlier about individual branches being able to totally screw you. And yet these APIs sort of necessarily have an extra branch that has to check whether you're advancing fast or not, whereas if you had two overloads where one could assume the value wouldn't have to do that check, did you experiment to see whether that makes any difference?
It would make a difference. I was just trying to not give 100 APIs in the first review. So how do people feel about going to that level of...
My personal opinion is that
Because it can make it is next and is next in advance.
We generally don't care about overloads because they don't increase the concept count that much. Like, yeah, they're more metadata, but it seems fine. Like, I think usually we prefer defaults now because it makes it clear what the default is by just browsing IntelliSense. But I mean, quite frankly, whether you have try v2 with 2 overloads or 1, I mean, that.
Well, one thing that could express it is if it was is next, but it was, and then the other ones were is next and advance, right? Then there's no question about, or less question about what the behavior is.
Well, would you ever pass in faults explicitly?
Huh?
Would you ever want to pass in faults explicitly? If you would, like basically, is advance ever going to be something that would not be literal? I guess it's a better question.
What about like RNA next?
So
how do you know if the bool should be one of the values or
Yeah, maybe you should return the actual. I guess. Yeah, for those ones, maybe those should actually return the thing that you found for the any's. How do you know which one you saw? If you say any next, 1, 2, 3.
That's a good point.
How do you return true and this one?
It's hard.
Yeah.
You'd have to have an out.
We had this somewhere else.
You'd have to do an out
No,
because
you have to do it out because T might be bool.
Yeah, well, default. Well, T. Yeah.
I mean, presumably, if you care about that result, you're going to be doing some sort of switch, right? You're going to be saying, if it was 0, if it was 1, if it was 2, if it was 3. If you returned -1, like we do in other things like index of, then that would just be another case in your switch statement.
Yeah, I like that. Seems concise.
Oh, doing it in, you mean?
Yeah.
And so if it matched value 0, we'd return 0. If it matched value 3, we'd return 3.
Yeah.
Exactly. If it didn't match anything, it returned -1.
What if T is int? What if T is int and you actually match on -1?
No, it's not.
It's
not
the position.
T,
It's not what the
position.
value is.
what if the T is bool, and then you don't know if you're actually advancing past or not, or searching for the
No,
value?
you don't return
Oh, that's
that
actually-
as not T. It's always int, and you're returning position
index of
in
where-
the value.
No, I think that was a different question. That's the question: is I call are any next true false? Am I calling the overload?
That's exactly what I
Or
was meant.
am I calling the true? If I pass true, am I calling the first already next overload or the second already next overload? You kind of have to know how the compiler resolution rules work.
I mean, to be fair though, who has a sequence of bools?
Sure.
Well,
Truth tables.
But in any case, that is addressable because you can do name parameters, right? So
That's a fair point.
so that is an out there, but like
And there is a very clear answer though what the compiler will do, and probably no one's going to do it, so maybe it doesn't matter.
Yeah.
so.
I mean, my question with the literal was more like if you pass in the advanced pass delimiter as a variable that is depending on state rather than a literal true, literal false, then if you make it an overload with a different name, then well, what do you do? Right?
Yeah, you're right.
But if you expect this to be either true or false explicitly on the call side, then having 2 methods is fine.
That's what I expect, but like it's not like we have a lot of like use cases yet. So,
Yeah.
I mean,
I got it coming. Let's put some guys.
What?
you've got a use case coming?
I got some people that have used these APIs, and they have copies of the reader of different kinds of readers, and they've used it in their project, so they should be giving feedback on using this in various projects.
So I'm gonna go with the like blowing these out. You know what exactly we look. Will you continue around like again, to get at the perp, yes, we'll have more surface area,
Yeah.
but like whatever, they're all the same. We're consolidating the names in the pages anyway, so that won't make it too terrible. Because yes, it does make a difference. That extra check to know whether we advance or not.
Yeah, I will say going through the pipelines review, what we ended up experiencing was making APIs nicer killed the perf in a lot of cases.
Yeah.
And it took us a long time to get it back after fixing the APIs.
Yeah.
So yeah, being aware of that is good.
So, and again, I can't beat this enough. Like, it's really, really easy to kill the perf on this. Super, super easy. So, advanced past and advanced to, and I think we can do this. See, this is another awkward one because like these ones actually return where they advance to.
Yep.
But we don't have a. If we want to return the concept of which one we get.
Oh.
But this is advanced.
Sorry, I didn't understand that, Jeremy. Can you say again?
So, the advanced pass return long because they return how many they advance. But you don't.
This is advancing past a sequence of.
But I guess it doesn't really
I
matter in
had
this case because if it's all three things.
17 spaces in a row, I would return 17 if I passed in a space. Is that right?
Well, like, if you had three of them, you would have to track all of them anyway because it's an OR situation in this case, right? So, like, which ones did it advance past? Well, I don't know that there's a way to actually represent the same thing as before. The other one's like one of. This one is, it could be all of them, it could be one of them, it could be two of them.
Does that matter though?
Yeah.
Like, is there a use case where you want to advance past several different things and then you want to know how many of each you advanced past?
That's what I'm saying is like, no, I don't think so.
Okay.
So I started going down that wall. It's kind of hard to, wait a minute, that probably doesn't really mean that,
Yeah.
so, whatever.
So is next any if you return the value you want you found? Is that going to be slow down the implementation?
No, it's index. We hit something, we have a branch there we would return, or set the value, and we would keep the one return. Measure that, of course, to death, like we've been doing already. We'd like to see, do we keep the int and then return it at the end, probably.
Use go to.
The JIT surprises me.
Does weird shit. Yeah.
So, we'll measure, and if I see that it's actually slower for some reason, then we'll revisit. The presumption here is that it would be faster to remove the check and return that data overall. And try read2. The try read2 is the one that returns a span in one of the sets, and this is the one where the allocation can potentially come in because it has to give you back a continuous span. So that's where my other things come in. So like the initial thing that I started with is like really the answer here is like if you care about the allocation of the span that you were asking for, like in the cases where you were going cross segment, you have read-only sequence to take care of that for you. You can do the stuff there. The only problem with this, like, so you can take the sequence out, and I've made that faster, or at least with this other proposal for like the sort of fast index or fast positioning. But it is still slower. Right, so to call that one, yes, it's optimized to look in the current span and do it, but like there's a lot more stuff in that method. It can't inline the whole thing. It's like it is a little slower, right? So the fastest one to go through is the thing that returns the span, because it like just is. We don't have to build a sequence. We don't have to do. There's a cost to making the sequence, right? So
Also,
the span can just end up being a slice. So like if you think through it, that ends up being pretty fast, and it's really hard to beat that. So
one issue is that outvar doesn't work for these because you overload on the return table first, the first argument. So to do try read2 outvar, it would just fail, right?
Yeah.
It wouldn't work.
Yeah. It won't be able to resolve it.
Yeah.
Well, yeah. So the other thing that I was looking at here was like having allowing you to pass in a delegate basically that like says for any number of reasons you can do this. Like one, you could say like, well, in one of the examples I was going through with Stephen last night is like say like you have a loop where you're reading through a whole bunch of stuff and you have a bunch of segments because that's the way you use your stuff or the way it's set up, whatever. And or you're going to be calling in the same way like you have an outer reader. you have your own buffer in there that you keep for that outer thing.
Yeah.
And because you know you're always doing it sequential, just always use this one. And if it's more than this, I know it's going to barf. Like, think about something that reads lines. You know, this is already a problem for people that our current APIs don't give you the ability to cap the size of your lines. So that's one way you could do it. You can think about something that read a line reader. You'd say like, well, here's my allocator for that.
Yes.
Like the biggest thing I will ever let you do is this. So like, I'll just throw in the case where the buffer reader comes back and says, okay, no, I need a gigabyte worth of string space for this, right? So that's one way of doing that, is to like, you can use it that way. You could write your own wrapper that like rents from the pool and tracks things that it's like renting and returns it, some disposable array pool tracker, et cetera, et cetera. I don't expect it to be easy to use.
Yeah.
I don't expect people to be needing it very often, but I think that it's a useful out, and that's what that
So the
allocator thing was.
The allocator is a type, or is it a delegate?
It's a delegate.
A type delegate, I see.
So I can iterate it. Just that's where I started. Like if having it be an abstract type would work better, then fine. I don't care.
So return a
Whatever's most performant. So just something that takes an int and returns a span.
Yeah, we don't have that. Unfortunately, we have span action. I think we don't even have a func.
Can we call it spallocator? Spanlocator?
Spallocator?
Spallocator.
But many times
Span
you will
locator.
want to stack alloc, right? And like with this guy, you won't be able to.
Huh?
Like many times you will want to stack alloc, like this stuff, right?
And that's where the peak stuff comes in. Like
Yeah.
you wouldn't want to stack alloc for the. This is typically the big scenarios, right? Like you or potentially big. This isn't like 64 bytes or.
So
100
today, when you implement the binary readers dot try parse little Indian int 32, you don't call this. You call peak first because you know it's
Yeah,
small.
so yeah, the actual exact algorithm is simply like,
Check.
do I have enough in my current
Yeah,
span?
yeah.
If I don't, then I call this other method just again to make the JIT happy. And the other method does a peek into the stack alloc.
So why don't you have a constructor that just takes a span as a scratch buffer?
Hmm?
Why don't you just have a constructor that takes a span as a scratch buffer and you just use that throughout?
Because we can't store a span in.
Okay, this is a rough one.
This is
Oh.
span.
It has to be because the.
But what size?
It
What size
catches the
span?
span.
128, because I mean all operations are like small, right?
No, it's possible. Like his point is, if you have data that's spanning 2 segments, it doesn't have to. It could be a string. It doesn't have to be 128. And we allocate and say, okay, your string started here and ended here. Here it is. It
For
could
bigger
be-
ones.
Yeah. So for bigger ones,
For peak it's
It's not
128. For
128.
bigger ones is.
Well, we wouldn't. If you passed in, like, it's possible we could add that as well for some of the other scenarios. To like, we would never. You'd only stack alloc once.
You could make the peak span be one passed in up front, and then you use that for all peaks.
Yeah.
That's one option, I guess.
Yeah, but that's for peak. And
That's what.
that's only for peak.
Yeah. So for
I think it's definitely worth exploring.
For everything else, you would need the allocator.
The devil's in the
Should
details
return
on that
memory.
one. I'm not sure
It shouldn't return
how
span.
useful. I think I'm definitely worth looking at to see like if there's any like design, like if that's something that can be layered on without breaking anything or whatever.
Yeah, how would you write allocators to that? Like, what would you realistically do in the allocator? You would probably go to the buffer pool and cast the
How do you
result
return it?
to
What?
span, right?
How do you return it from the? I guess you return.
Well, you track it.
after you use it. You track it yourself.
Well, because like you're being called, your stuff is being called.
Right.
why
So
should
you call
allocator
rent-
return memory?
Because there is no point in limiting it to span, and maybe you'll want to allocate read-only sequence, and if you have memory, it's easy to do. If you have span, it's impossible to do. And like, there is no advantage to having it being span. You cannot do stack alloc as stack goes away. And, like,
There's one advantage to it being a span, and that
No, actually, technically
you're,
you
you're
could
guaranteed that
before,
the sequence reader
and
can't
then
shove it
pass
anywhere.
delegate
Can't,
to
like,
reach
Can't
that.
store it. Yeah, you're right.
yeah, but
And getting the span out of the memory is actually slightly slower, right? But I don't think we.
but
and this
you'll
is
get
only-
it, you'll
this is
get
a
it
rare
anyway.
case.
You'll do something like new byte array dot out. Yeah, great span.
No, because you could pre-allocate the stack and then use inside of the delegate. You could just give a substance of that
True.
thing.
Yeah.
What?
He's saying like you could stack allocate before you
Wait.
go in and have your.
But you aren't allowed to capture span allocated locals
I'm pretty sure
into
You can't, right?
How would you
You can't
access?
capture it.
How would you access it from your delegate?
to capture. You have to
You would have
allocate
to,
something.
you would have to capture it, which the compiler would not let you.
Although you're already having to, if this is taking a delegate, you're allocating a delegate.
Yeah.
You don't get access
It's
to
gonna
it.
get hoisted to the heap. So you can.
Oh yeah.
But you could probably do it with stack unlock and unsafe, but you would not be able to do it.
Of course, the other way to do this, of course, is just get in those cases just use the read-only sequence, but you're going to pay the price.
Yeah.
In the cases where it doesn't. Again, creating a read-only sequence is not free compared to like slicing a span.
You slice the sequence though, right?
Huh?
You slice the big sequence when you create the sequence, right?
Yeah, it's based off the position,
The current position.
and length. Yeah, so like it's
I mean,
there's a fair
the
amount.
alternative.
Yeah, well, not only do you have to construct that object, but you have to like it has to do the logic to get you the right
It
pieces.
should be free, not free. It should be cheap, right?
It is cheap, yeah, but it's
It's
not as cheap as the span.
yeah,
That's
okay.
that's again that's the point.
Okay.
So like if we're talking about the 4K buffer scenario, like
If it's chunky, yeah,
you're
it's
almost
fine.
never calling into that, and then like or needing that extra functionality. Then the rare case where you do. I mean that's internally the way we have this
I like
implemented right now is in like the span, all the things that do the span stuff. They try to work on the span, then they call a helper that does the read-only sequence, and then they like use the read-only sequence to whatever.
I do wonder if this pattern could be generalized and used for things like so we have the low level thing. What's it called? The thing that returns you if it needs more space or if what's the thing called?
Operation status?
That thing.
Yeah,
that,
yeah.
That pattern where you call try blah passing a span that's too small. It tells you
So
it's too small.
in-
Could you use this to replace that pattern? I guess,
So
or build a pattern on top that kind of uses this to allocate memory.
So, like one of the
Yeah.
options we were looking at, actually based off the feed last week, was actually redoing this thing so that it always returns positions of some sort or a length. The problem is that like,
I prefer this.
well, it's really hard to use.
Yeah.
And then you get
Well,
tanked with like. So I'll finish with it. I'll get to yours in a second. Like the problem with like doing this thing is that then you have to return some sort of quad state because it's like, well, did the operation do what I expected it to?
Yep.
Okay. Did it have enough space? Did it not have enough space? And it goes on. Like you have to like do a lot of sort of juggling or turn into like 3 different outs to like here's the result, and then here's this thing about the buffer,
Length,
and you also
and
pass
then,
in the buffer, and like it gets pretty awkward. So it can be done, but it's super awkward, and it kills the perf because then you have to call back again to get the data, right? So this gets back to the point that I keep beating with a stick is that like every single little thing is not free.
It's interesting because if this makes the perf better because you don't have 2 calls, I wonder if you should have this pattern in more places that have the whole try blah pattern that returns false if you can't do it.
And some of the now to be clear, like as far as like expanding that out, part of the reason this makes such a big difference is because the work that's going on here is simple.
It's simple, yeah.
There's not really.
But David, you're suggesting the opposite. He's saying like we replace operation status based pattern with this using this. Which is different from what we previously discussed, which was change this to return operation status.
Yeah.
Well, yeah, I'm going back to the operation status thing is like why we didn't go it this way to illustrate like we did actually even look at that, or
You did?
I did. Well, making this do operation status.
But he's talking about the other opposite, the
Yeah.
inverse.
So
So
I'm saying today we added a bunch of calls on like various APIs to return a status and a bool and other things.
Outliers.
And I'm wondering if this pattern may be easier and maybe more performant in some cases, instead of having the caller have to retry a bigger span over and over.
and I think the fundamental thing is again like how much work is that thing doing?
The difference
I
is there's
think
no
like the
destination.
main scenario is like you actually need only one operational buffer where you need to copy. So maybe in terms of this you could implement that. So you could, an example, like pre-allocate one span and then like kind of in the delegate you always give the same kind of buffer, and then like whenever you loop you always get the same kind of data. And so I feel like the kind of that would be like the only kind of useful scenario. But like you can implement it in terms of this. So I think I'm like this.
I like it.
So
I
one place where this doesn't work is in like the parse, right? Doing this pattern, because like we constrain parse, and that's the next part. If you want to scroll down to that.
I had a quick question.
Sure.
Why is this unmanaged instead of just struct?
Because I need to get pointers out for performance.
Can't you just use unsafe? Because there's a number of types.
I don't
which,
want to use unsafe.
No, like the system runtime compiler service is unsafe class. There's a number of types which are not unmanaged and can never be unmanaged, but which are blittable and may fall into the category of things you might want to use this for.
Really? I thought the whole point of unmanaged was...
Are there scenarios for this other than byte and char? I'm serious.
That's all I cared about.
Structs. I don't know.
So, like, I didn't feel it was necessary to artificially restrict it any more than that. Because, like, I went.
No, I agree with that. I'm just wondering if we
so I said,
should...
like, floats and inside. Like, I can kind of imagine people wanting to do some stuff with that, or like having, but like, I really wasn't. If somebody finds a scenario to use it with some struct that's like meets the unmanaged thing, fine. I'm okay with that. Like, I don't care. Like, whatever. But like, we're designing for bytes and card. I think I call it out at the top.
The other problem is that unmanaged may not be supported by other languages and is only usable on C# 7.3 and above. So if we just had struct and had a constructor check for like, is this a blittable type, then that would probably meet the same purpose and be more usable across languges.
But is a blittable type is expensive, right? I don't know that we have any.
It's not expensive for primitive types. It may be more expensive for user structs, but that would be a one-time check in the constructor.
Well, we create the subject for what?
Sure, that's. I'm actually measuring construction.
As long as the purpose and bad for bytes and chars is fine.
Yeah, because for like byte and char, you can just have a type check which will be optimized away by the JIT.
But just for the two issues you mentioned, so for 7.3, this is only going to ship in .NET Core 3.0, right? So we don't really care about 7.3 or not. And
well, you might care about
like
7.2. Some people might be using C# 7.2 on Core 3.0.
Yeah, I don't really care about them, do we?
Like why would you do that? Yeah.
They might have other requirements for interop or other purposes. Like, unmanaged doesn't work in VB, it doesn't work with F# at the same level because F# has a different unmanaged constraint.
Mm-hmm. Well, I don't think we care about VB.
So ref structs don't work in VB anyway.
Yeah, so that's why I would basically say I don't care about that part. But, I mean, I think that, so the unmanaged, we should look into this because we had other APIs that we constrained it to unmanaged. And I think Jan gave similar feedback on this, that it's not what you want usually.
And there's a new champion proposal to basically make unmanaged completely pointless because it would allow you to start taking pointers of generic structs, which if that happens, then, you know, unmanaged is useless because you could just take the address of T if it could be statically checked to be...
The only reason I'm doing it is that, like, again, I can, like, pin easily, and just for that functionality, right? I didn't have to, like, jump through any other hoops. If you can share with me the alternative, I appreciate it. I'll look at it.
I guess.
My only feedback is I don't think we should be, like, it's fine if we can get rid of the unmanaged without hurting anything, great. But to me, I don't see any use for this other than byte and char. So trying to expand it to arbitrary T's doesn't seem like a particularly, something we should be spending a lot of time on.
Yeah, I won't, I agree, I won't, like, lose any, I won't take a hit to byte and char to make that happen. The construction, whatever else. Because, again, wanting to construct a lot of these, there's already a problem because of the size of the thing, constructing them, but, like, it's like almost 100 bytes.
Steven, what are you suggesting? Since it's not used for byte and char, does it have any implication on the API surface, from your opinion?
I haven't seen anything.
Okay.
So, all right.
Just something you had in mind, Austin?
No, I was thought maybe you had a concern with it being generic, but that's the only way you could support byte and char, right?
No, it's no way you could really support both without losing anything. Right. It's just you're trying to add things that would make it more usable with other T's is sort of, I'm saying we shouldn't do that unless we have a real use case, but I'm trying to think of one and I'm having trouble.
But we can't restrict
ML.NET.
We can't restrict the caller, right? That's the problem. Sure, we would want it for byte and char only, but how do we restrict the caller so that they only pass in byte and char?
Well,
I'm not saying we have to. I'm saying we shouldn't go out of our way to make anything beyond that.
So you can help with the ML.NET, come up with some examples. Double. We'll look at that. So can we go down to the parse ones?
So what did we say about add last segment? There was some feedback on that one, right?
At last.
I need to iterate with them about the actual implementation.
Yeah.
But, like, we need a method there. I don't know that we can iterate on the name on it. Like, having people trying to calculate that out on their own is not a good idea.
If this method exists on read-only sequence, If such a method exists on read-only sequence, would we even need it here?
Huh?
If a method that tells you I'm in the last segment exists on read-only sequence, we wouldn't need it here, right?
It's position based, right?
Oh, okay.
So like, yeah, because we keep two positions
I
in your
see.
sequence position. I don't. If you can tell it straight from sequence position, then great. If not, then we need to like deal with it.
No, you have to have
So
two positions.
I trust you. we'll iterate that, but like that was my argument. I thought it was that simple, and then like, well, if it's that simple, we should just expose the sequence perhaps, and like, no, we'll do the other one.
Good example of good intentions.
Yeah.
Just about try read 2, if the delimiter is not found, what does it return?
Huh?
In try read 2, if the delimiter is not found, does it return the entire sequence or just returns nothing?
Nothing.
Okay.
Try read two. It has to be successful. So bool would mean it found something.
And
False means it didn't.
But that's
You know, and
consistent
you
with all
know how
tries,
far
yes,
it
right.
went because you know in the out that you got. You can look at the length. So if
nothing
the
like
next one
split,
was
string split, if it didn't find it, it returns the entire string.
It's not tri-split.
so you would
Sure.
you would be able to do that because if it were in your own logic, if it returned false, then you just use whatever you take whatever's left.
That's what I'm saying. Like try without, like
It advances, right?
expect it to be.
Try read advances.
It has a parameter.
Has a bool. And default is true.
No, it advances on,
Yeah,
on
the
this,
default is true, yes,
Yeah.
because you're normally.
but it's advancing
well,
past.
sorry, no. Go back up again.
Yeah.
Was it true? I don't want to lie.
You will laugh.
You
Focus,
you said just a little bit up again. So
Yeah,
it's true.
Yeah, good.
But
There are some cases
yeah.
where you don't want the delimiter, and like,
Yeah.
but like I thought the normal case was at least in our iteration.
But all this advances. It's only that bool is
It's only
for
that
the last
bool,
delimiter.
that's the delimiter. It's an advanced best delimiter, yes.
It advances up to it regardless.
Well, try read it
Yes.
doesn't make any sense for advanced. Then you go to peak territory.
Yeah.
or something like
Peak
that.
is don't move.
So using extensions, the idea, like, we have two sets. This one you can kind of ignore for now because we don't have a UTF-16 parser, and that's a problem.
Yeah.
One of the things we're missing. But that conceptually, that's the idea, is that like we do a UTF-16 parser, and then we have one here that a set of extensions that takes call. But the try parsers that take the fight assume everything's UTF-8. The ones that take
I
are
see. Char. I
assume
see
it's
char. I was like, where's the difference?
Huh?
I kept seeing the same answer. I was like, where's the difference? It's byte versus char is the main difference.
Yeah,
Yeah.
they're exactly the same. They're the only.
Oh, it's the
We
only.
don't have a UTF-16 parser.
Yeah.
But like,
I was like, where's the
UTF-16 comes in like Lithuanian and Backendian flavors, so like,
Huh?
but this same API could apply for both of them. Feels like there should be some kind of way of telling what encoding we're using.
Big endian versus little endian?
In the charge.
Sure, but it's sort of all. That was more meant to be more illustrative because we have a fundamental problem where we need the UTF-16 review. Because the behavior, we didn't do it the first time around because we have these other parsing stuff. The problem is like now it shows up with this thing is that like the actual semantics of UTF-8 parser are radically different. And when you're going through like our existing parse functionality that's in the framework, you tell it where the data ends. UTF-8 parser tries to find that out on its own, right? So it reads until the very first not valid piece of data, right?
Does that have
So it has some fundamental issues, and like this is one of the things I had to deal with here is that like our UTF-8 parser will take, for example, any number of preceding or trailing insignificant digits for most of the things. So you can have a gigabyte worth of zeros, and it will happily read off to nowhere land. That doesn't work very well when they're talking about crossing segments.
Yeah.
So the iterating on this for a while, like Christoph in particular, you know, I spent several hours talking with Aston about it as well. When you take in like reading floats and all the other things that come out of this, like once you look at all of them, the only real sort of cross or rational thing that we can come up with is like we limit all of our parsing to essentially 128 T's. So if we can't make a positive assertion within 128,
We throw.
we don't throw, we just return false.
False.
So that's what you get. So like the basic, it's all highly tweaked to be as efficient as it can be in the cases where we can, without tying in too closely to the actual logic. Because the hope is that like we might add additional formats in the future. We don't want to have to like iterate on this, but the one scenario would be like, say you're trying to read out an int, it has 100 or 200 zeros in front of it. You know, we would read, like, say it's all in one span, you have 4K. Well, yeah, we're going to pass that span over to the other one. It's going to read out some ridiculously huge int. It's going to read all these things and give us back and say it consumed 220 bytes, and we're going to say, you know, that's over our max. So what we're looking for is like it consumed less than 128 and return successful. But we also have
if you parse an int that process segment, you parse a byte that crosses segments. I guess byte easy. I need something harder. Int is harder.
We stack alloc for those cases when
you stack out 128, and you copy up to 128 bytes.
Yeah.
Okay.
But again, only in the
to parse an int.
Huh?
Why do you need 128 to parse an int?
Because zeros are.
Oh.
It's a max. Is that
It
going
comes
to be
with
user
reading
configurable
Yeah.
max?
Yeah.
Is that going to be a user configurable limit
It's text, right?
for like 128?
No, because it's really hard to.
Can you leave numbers off?
The idea is if you need more than that, like you can do your own if you have to, but like it's really hard.
You pad by 0.
With this whole set,
yeah.
like
So
the
we
basic
just
ones
say-
that we have with particularly time span good and floats and things like
yeah,
that,
okay.
it's really hard for someone to know
You have to
how to like pass. Well, for one, for us to write around some arbitrary number that's coming
for
in
JSON. You have like
to make a decision.
actual things around it.
Like what happens if you, like we would have to make some sort of like kind of crazy rules, because like you pass and you say, well, we want to read 10 as a max. Well, you can't even get a valid value for some of these things, period. Do that in logic to do any of that. Sort of thing.
So for
So
example,
like all that complexity I just said like very well, 128, it's very easy to document that. And if that doesn't meet your needs, if you really need to read or you have multiple choices. You need to handle this thing where you have a whole bunch of zeros ahead. Well, then you skip past any, and then you start reading.
Yeah.
Skip
So-
past.
Yeah,
so
because
for JSON,
I'm sorry,
right,
advanced pass.
you look for the delimiter first. You find the AND token before you parse the int.
No, you can parse it in and then check if the token is there.
Either way, yeah.
Why go?
I guess it's fine.
Why go backwards?
You've got options.
yeah, the one case that I was worried about
You
is
have
like
to listen
128 seems pretty
most of the
small for
time,
like
yeah.
if you're parsing a lot of data, that's not even sufficient to take advantage of like a vectorized algorithm to make this
So I don't use
fast.
this.
Because that's only 8 reads, which is for 16 byte, and that's about what you normally do in the inner loop for a search algorithm.
An interesting data point here that like people may not be aware of, but like all of our float parsing is hard capped at 50 significant digits.
That might be
Really?
changing.
Well, that's part of what drove the 128 here.
So is the 128 tied to stack alloc, or is it just independent of that?
It's what fit everything and seemed rational to be putting on the stack. In the cases where we have to put it on the stack, we don't arbitrarily.
I'm kind of curious because like there's a couple of other laws like datetime and like they kind of depend a little bit on globalization and like how like each country like kind of formats the
Invariant.
They're like all of the stuff that's there is invariant. So like this isn't completely future proof, but it is attempting to be semi flexible.
It matches the UTF-8 parser we added in.
It calls
that, right?
It calls the UTF-8 parser. There is an option. Like basically, we have multiple options, right? We can use the UTF-8 parser. Good, we aren't like duplicating logic. Bad, UTF-8 parser does not really handle this idea of like things being broken up in chunks. And so, and UTF-8 parser is also still based around this idea that like the end is the end. So like, which we already illustrated that there's another caveat to this is like, well, what if you go back to the pipe reader for more data and that data was going to be valid, right? Well, the current assumption in here is that like the end is the end. So like if you read, because that's the other thing on it too, is like, well, if you read it said true and it was less and we're at the end of the buffer, right? there's no more sequences left or segments, then that was the right number, right? That was the 1, 2, 3, and then.
So, but this is the same as what UTF-8 parser does, right? I thought the whole point here would be.
No, but the UTF-8 parser does not do that for. So we consider the read-only sequence the end.
Right.
The UTF-8 parser considers the span the end. So.
Is that fine for you guys?
What do you mean?
The fact that read-only sequence that you have in the sequence reader is considered the end.
So there's.
Yeah.
Yeah.
But
What you never have an issue where you have numbers or tokens straddling segments of pipe reading.
you
It's
would
possible.
have to have a separator after something of variable length to know that you're done.
Yeah.
And that's a
Okay.
requirement. To
So
parse something and then say next thing has to be blah. So like you parse it in and then you, for JSON you parse it in and then you search
check
for a
the
space
number.
or a comma or
Since
like a closing bracket.
these are relatively open-ended, the kind of the thing he's throwing up here is like, do we just always make it require that you have 128 bytes left?
No.
No.
Like you can build 3 bytes and that's it. Like it's 1 to 3 and
Yeah, well,
Weird,
yeah. So
JSON doesn't necessarily have to have a delimiter. It could be a single value 1, 2, 3.
What?
and
That's valid JSON.
What? Top level?
If I have
Without a
JSON
property.
payload, nothing, just digit 1, digit 2, digit 3. So how do I know it's 1, 2, 3 is the end or is it 1, 2, 3, 4?
then you have to pass isEnd into
With
JSON
that.
parser.
That's what I have today. But the buffer reader doesn't accept isEnd.
No, but into JSON parser because
Yeah.
it's information that parser has to know. BufferReader doesn't
Okay.
care.
Yeah, it doesn't care.
so
So you'll have like next thing is end or
Right.
as some delimiter.
Do you guys
So-
not have this concept in anywhere else? Where
We
you can
have new line everywhere.
Okay.
Yeah, new lines and
New lines are our delimiters.
Our delimiter.
So
or we
our-
seek a delimiter before and
Before
get
parsing.
the whole thing before we parse.
So arguably, like, I mean, the other one, which doesn't really seem plausible, is to write a whole other set of parsers. And I don't really want to do that, but like, even if we did do that, we would probably not do what UTF-8 parser did, and we would actually have some sort of constraints on things. Like, it's unfortunate that like, you can be in that state where you can have, again, like, multiple gigabytes worth of stuff that you're limited by int. So there is a cap, but
Is
it
there a security concern if someone zero pads some integers? No, the other way. And we now miss a number that we actually want to read?
Oh, no, I
No?
don't think so.
Okay.
Did you consider adding size as an argument to this method? Like,
Well, yes, when I was calling him, it's tough.
Well,
Because like we're trying to be highly optimized. Like, what happens if you pass? Like, we have to check the size that you passed in. Like, you passed in a size that it will never succeed, right? Or breaks the rest of our logic. That we've got some hard coded stuff in there, or assumptions. Like, for one concrete example, right?
Don't
Is
we
that-
still have to handle that in the case that the remaining bytes in the reader is less than 128? Like if you're trying to parse and you only have 4 bytes left in the span, that's less than 128. So we still have.
Yeah,
to
but
handle
the GUID is a very specific size. So is Boolean, for example. It's always 4 or 5 bytes, right?
Right.
So like, you know, I deal with that on the existing thing. So like, I would have to get an additional check or like, I don't know.
Because in both cases, you're basically having to say that the limit's either whatever the length of the span is, or
So-
it's whatever the upper limit is.
So one of the other issues with that too, of course, is that like the additional arguments would have to be passed through to the helpers, and the helpers would have to then have additional logic in them to decide whether to stack alloc or whether to heap alloc, depending on what you had passed in. So there would definitely be significantly more complex.
So why would you care about the size?
well, if I don't care about ints
So
of 100 bytes, don't allocate that much stack space, even if read-only sequence has it.
so you also
about having it less than 100.
Yeah, I know that my ints were 8 characters max.
So you also have the ability, of course, to like hyper optimize out of this, and if you know that you're into say
Yeah,
bytes,
then I can do it on my
read
own.
out the bytes and you pass it to the parser yourself. So
Like if it was just
the UTF-8
as
parser.
free as adding like argument with default value of 100 and then allowing people to set it to different value without losing the performance, it might have been.
Well, I agree. It's just like I don't think it's
So
possible.
you care
to
about
do
the
that.
stack
It's
alloc size, or
significant
like
complexity.
not
Like,
sure what?
yes, stack
Because the
alloc
stack alloc
with
size, like it's
branch
pretty
list
much no op,
single,
like if you allocate 100 versus
max
10.
statement where you
Yeah, 'cause it's
basically
like
say
just
pick the
increment-
max of the user's
incrementing the
input or the
number,
length
right?
of the span.
I mean, You
So
run out
I'll-
of text
I'll-
space.
I'll
Yeah,
agree
this
with
is-
you on
it's
that.
not-
Like,
it matters.
text space is not.
Isn't it zeroed out?
It is zeroed out.
It is zero.
Yeah, but I think
It's not free.
I don't know what that.
but
Yeah,
assemblies in Corefest have the flag to not zeroed out.
And
Yeah.
the
Only in core
skip
effect.
look
So
net flags.
actually, I should lay this down as well. If you know how many bytes are supposed to be next for what you're parsing, you should not use these methods.
Really?
No, because like you don't. Again, it's using UTF-8 parser.
But it does the hard part of like if it crosses boundaries.
Yeah, it does, but like you can do that yourself with peak.
Yeah.
That's the thing.
Oh.
Like, so you get peak.
Okay.
Like you know, like you really you want to be constrained, and I'll actually put that in there. Like if you know that like the next 8 bytes is your int, for one, it's going to fail anyway because like what might be beyond that is more valid int data, right? Which is not what
Okay.
you want.
Yeah. Okay.
So like there's a number of reasons. Like if you know the end, you should be passing the end in, and peak is highly optimized for that. So this stuff is all.
Sorry, I'm lost. Like, how do you, like, what does it mean? So, like, let's say I want to parse an int and I know I have a maximum of 6 bytes that I expect. How would I use try peak for that?
Try peak.
You stack along 6 bytes, span of 6 bytes, you passed it to try peak, now you have a span and you pass it to UTF-8 parser. It filled it with 6 bytes.
Oh, I see what you're saying.
You inline it to that, or if you want to be extra fast
then you're
about it, you
advanced by
check
6.
what's left in the current
Not
span.
by
It's
6,
like what you
by
do.
what
Massive.
UTF parser returns.
I see.
Oh yeah, yeah,
And then you
yeah.
call
Try
peak.
peak,
You call peak if you
whatever
have
the
to.
try peak return.
Or your try peaks are all cached because you've done a whole bunch of them in a row, and you just make it simpler that way because you're using the same scratch buffer for all of them, whatever.
Yeah, I forgot the signature from try
Yeah,
peak.
copy buffer. And then you advance past whatever the size of the return span was here.
That's essentially what we're doing internally. It's just like we have to deal with.
Yeah.
We have to deal with.
Or even what the UTF-8 parser return. The UTF-8 parser returns bytes consumed. You advance
But
past
with,
that.
with additional optimizations
Yeah.
about it being sort of semi-unbounded, like say 28 thing. So these are much easier to implement. I don't see any reason why people would ever need to go out with it. But like this is the binary reading stuff. We have to try read a T.
Should the NDNS be bool or
No.
machine NDNS maybe by default? Have a machine
No,
NDNS.
a lot of protocols have fixed endings.
So like,
Network protocols would say I am with NDN.
Okay.
So using machine dependent NDN.
that's been my experience too. Like with like format specifications are almost always like a very specific NDNS. So if you don't care about NDNS,
Mostly big.
like because you have like think about reading a header out of something and you have a struct and that NDNS is already reflected in your struct definition or should be for most things. If not, you've dealt with that, whatever. Like you can read right straight into that struct. In the case of the other ones, like you're reading through things individually, pieces of data, your spec actually tells you the things in little endian and big endian. And that's why I had them separate. And I didn't bother, you can cast it yourself to the other bits and pieces. I didn't think it was
I never
necessary.
remember what true or false means in this context.
For which one?
Well, if you would make it a boolean, right? Like, is true big or little, right? Like, it's not very clear.
Oh, when you're
Yeah,
passing
this is forever like
Here, I might
ambiguous false side.
Which ones?
He's talking about like if we had tried read int and it was passing in big endian, little endian.
No,
You'd have to use
the
it.
name is
Use it.
better. The
Yeah.
name
You'd
is
have to
better.
use an enum and it would be, you might as well just.
I think Mark is
It's also
name.
faster.
It's also
It's also faster.
oh yeah.
Not
yeah,
to check bool every time.
Right.
Oh yeah.
Yeah. I mean, the method name. Oh, you'd have to use to make it clear. You'd have to use an enum, and at that point, why not just put the enum in the method name, and then you're done.
Yeah, well,
That's what you got,
that's essentially where I ended
Yeah.
up. Yeah.
Well, you're just using named argument, but yeah.
So
Yeah,
the,
like,
these
it's
are the
big.
ones. Again, there's not a lot of work that's going on here, and again, this is the sort of thing where like it dies when I'm trying to do span. Like, because if you do a span only version of this, that's where you get like 60% faster, right? Because like it doesn't have to check the
Because
next
the
one.
checks. Because of the.
Like it's one check. It's like one line removed, and you're almost twice as fast.
Really? Why?
Because there's no
Don't we,
body. Huh?
don't we push that into a different non-inline method? The
We do.
cross
Yes, we do.
And it's still.
Yes, still 60%.
Come on, where's the JIT people?
We have a whole lot of threads open up with the JIT folks.
Okay, but it'll get faster next release, so we're fine.
Yeah. So like, well, there's plenty of opportunity for. This is already fairly well known, I think, internally that like there's plenty of headroom for us to continue iterating on making the spans faster for the JIT, right?
Problem is we
Awesome.
can, like all optimizations we want, we can just never ship them because we break too much shit.
Yeah, it's a slow process for damn sure.
If you just wait long enough, you get faster.
It's
some
just,
point
it's just
you hit-
really,
you
it's
hit
really
one
hard.
drops and it
Well,
broke everything.
we're up against two different things, right? With any of the JIT stuff, is like there's a limit to how much work you can do in the JIT, and then anything you do in the JIT is inevitably going to break a million things, so it takes them forever to like iterate on every little tiny change.
Excuses.
So, like,
Can you explain the first API? What's the constraint? Value type
That's
unmanaged.
Emo's tool.
Oh, sorry.
No, this is
Most of the
yeah. I think
Sorry.
this means
Unmanaged?
unmanaged.
It's,
Okay.
it's
It's
supposed to-
unmanaged. I assume.
Sorry, you can see that I copied this out of a reflection tool.
That's Emo's tool. Dying on. Fix the emo.
So
Oh, I
this
think that
is
rolls
all
off the
versions.
tongue.
I'll fix that. Boy, I totally missed that one.
Well, it's our new teammate, value type rec mod unmanaged type, or Reki as we call him.
Scroll down. I am interested in overloads that are for strings. Do you have anything for strings, for creating actual strings
Not yet.
from bytes?
Not yet.
You should never want
that's
them. Why would you
in
want
my
them?
that's in my futures.
I agree, but people, yeah, you do need it.
Yeah. So that
Encoding.get bytes to string.
Pretty much that, working across buffers. It's one of the most common ones I've seen people ask for.
And without
So-
creating a byte array,
Using string
if,
create.
if you span
So we have
multiple segments.
Oh, because you. Oh, I see. I see.
Like you can
that one I definitely want to iterate on with you guys and the people that like I just didn't get there yet. It's in my
Okay.
list of like
This,
things.
this is good because this is the baseline.
So like these other quick, I think we can get through these ones quick. And like wanted to add an extension to buffers to say
Yeah.
as span, so that like you can
Ooh,
pass
nice.
the copy buffer.
Yes.
So this is to address that part of like, well, I want to use the read-only sequence and I want to like put it together myself if I have to, and like, well, all right, we don't have anything for people to do that right
We
now.
actually have this in 4 places in Kestrel and in Signaler.
As span.
We do two.
As is a little.
Yeah,
'cause it's
is
gonna
it
copy
maybe
it.
two span.
Maybe
Two
two span.
Two span.
And the fact that it's efficient, that it doesn't allocate, in some cases, a better optimization than the fact that it does allocate sometimes when it's called an as. Like, as makes me think it's free. But it's in theory
Is
not.
there a benefit to this being an extension method rather than instance method?
An instance method.
I'm just asking. Yeah, on read-only sequence.
Wasn't there an issue with like? Well, that was more with span. I guess.
No,
I
we
don't
could
think-
actually
Don't
add
we
it
already
on-
have
It could be on the sequence actually.
an
correct.
as span method.
Is there a problem with that? Can we do that without
I
breaking?
guess the only thing I've ever heard was the JIT time of generic.
Yeah, well, we did that. We did that explicitly for span, but
Yeah.
only because that was like super high.
This seems good to put on this thing, so to be honest.
Yeah.
All right, so like, I'm fine with that. I was just like from compatibility standpoint, I just started with extension.
The only thing though, like passing in a buffer here, is that whole problem where you have to allocate the column has to
Yeah,
allocate
you
a
have to know.
buffer.
You have
Well,
to know
The
how
thing is, source has a length.
Well, you have to allocate. Don't you? You'll have to pass that in,
So the usage is you slice first. You slice some max length.
but then you'll have to allocate something to be the copy
That's
buffer
the
that
issue.
doesn't get filled in
That's
if
the
it
issue.
happens to be a single.
Can't
segment.
this use the span? What's it? The allocator pattern too?
Sure.
I kind of prefer that.
That might be a little
because
better.
If you
Because you don't want to allocate
it
it
up
I
front.
agree,
up front if you don't have to.
and I actually that makes some sense
Allocator's
because
nice.
like then we can even set it to null and it will allocate on its own. By new.
Yeah, just have a default allocator.
Yeah, the default allocator is just new.
We gotta figure out where to put that thing. That default, that pattern. Where do you stick those things?
System dot buffers.
Yeah, allocators.
Span allocator.
Buffers extensions already exist, right?
Huh?
This static class already exists.
Buffers, yeah.
Yeah.
So, and then the last one here, this unsafe thing, let's just scroll down just to read it, and I think that was-
Oh, sorry, again in the wrong window.
So, I called it something with a godly long name. And
Unsafe
I don't know if we
position
can just put that
within-
inside of the read-only sequence as well. I didn't know that we could. And we can make it not browsable, I don't know.
I would make it static. With
Yeah.
like read on the sequence of the dangerous get position,
Yeah.
and you pass in read on the sequence
Make it hard to.
Make it hard to find.
hard to find.
and scale it to pro.
Dangerous. Do you know what you're doing? No, but yes.
Don't we already have marshal types for this fucker?
Yeah, we have that sequence marshal.
Marshal
Sequence
thing?
marshal,
Yeah.
Put it on there.
Put it there.
Maybe there.
Sequence marshal that.
Okay.
Dangerous, get. Unsafe, dangerous, hard.
No,
hard.
unsafe is enough. Like we
Can we
don't
just put hard
have
for
to
now?
make it.
But if it's sequence marshal, we don't have the unsafe keyword there. We just use regular names.
It's not unsafe in the way that your process would crash.
It's dangerous.
It's just you might get a.
Well,
In- in-
you'll fail later as well.
Yeah, you
Yeah,
get an
but-
offset that
but not-
might not mean anything in the actual. So.
Well, yeah, when you go and use it, it will like
Yeah.
it will give
Yeah,
an
but
index
there
out
are
of range.
levels of unsafeness because unsafe class in system
Yeah, no,
compiler
I
services
get it,
you
yeah.
can crash if you do.
Yeah.
wrong
Unsafe
things.
might be a bit, maybe dangerous.
Unsafe is used in different contexts. Unsafe
I
for
mean, if you're
threading
putting it in
means
sequence marshal, then we should just use a regular name.
Yeah, that's true.
That's true, and it
It's-
says
it-
within segment, so.
Yeah.
If it's in
So
a scary enough place. and
I think that's
it's
fair
reasonable.
because like again this is not like this is you won't buffer overrun
Right.
you and end up with an AV. You won't get an AV out of this. You'll get an exception somewhere probably.
You get an offset into a segment you didn't
you-
expect.
Yeah, well, there's
It'll be a
that.
different
That's
segment.
that, or you'll end up with index out of range.
Oh yeah, I guess I see. Yeah, you just get it.
I think in
Ask me
general
how I
we
know.
have. I think in general we have put things on the marshal and the with the unsafe prefix, even if it's not itself being an AV. But this scenario is very often you do it in interrupt, right, where you really want to avoid the additional costs of calls. So in that sense, I think unsafe is fine. I think we only have one dangerous API in the framework that we call dangerous something.
We have something called unsafe in the marshal API.
Yeah, it's dangerous get ref or something like that.
Yeah, we have dangerous. What was this? Dangerous
Safe.
add
There's
ref,
dangerous.
dangerous
Yeah.
get handle, dangerous release. Like there's very few examples. Like most things are unsafe. That's our prefix we have kind of settled on, for better or worse.
All right.
But where this is going in sequence marshal, we don't have any unsafe.
That might be true because we already said it's on sequence marshal,
Right.
so the name implies use it at your own
Marshal
risk.
infers unsafe.
Yeah.
really it does.
Once you have to write using against interrupt services, like
Okay, that's true.
Have you used Marshal, the class
Yeah,
itself?
we need to
How many
analyze.
unsafe things do we have in there?
Everything.
How many of them say unsafe?
it says interrupt services, it's dangerous.
So
Peek and poke, man.
we'll look at the I'll run through this really quick, the last parts of the details.
Sorry, like I'm fighting with the mouse. The
So
mouse is winning right now.
advanced pass grab, any
Why can't the API that you're suggesting be on sequence position?
Huh?
The update sequence position? Oh, okay, it can't. Okay.
Because
Yeah,
like
yeah, you're trying to
it
do
has
this.
internal detail
Yeah.
of that flag, that bit flag thing is an internal detail of the
Yeah.
sequence.
Don't leak it.
So
Scary.
That's
public.
that's the parsing thing. So while peeking ahead, that's the peak thing being awkward. I call that out here.
Right.
That's on performance parsing. I'll talk about these futures. And so like string convenience methods may be useful for read line, etc.
I think we need something.
So I agree that we need something, and I need help from you guys to help define that, because I can imagine things, but like. it's very
Oh, you actually
fine
proposed
stuff.
an API, not just as a sample. I thought it was a sample.
What? Oh, this?
Yeah.
Oh, this was just showing an example of other things. It's like the other thing that shows up in parsing all the time is that like things are set up as like the ABNF stuff is like everywhere, and it would be nice to write these things for people and like do it efficiently. Right, because like you want to like have overloads that say like, okay, well, I want to OR these things together because that's what the rules are for this thing. You can be smart about this by like, particularly in the byte scenario, by building tables or whatever else. And
I think standard.
It's really clear to define what those rules actually are.
yeah, that's
With
straight out of
alphas.
the spec, right?
Right.
So like I have it linked here. I didn't actually put the RFC number, but it would
Oh,
be,
I see. Okay, there. I see.
it would be everything here would be by RFC or whatever. I forget which one it is. Just
God forbid that you.
I've done a lot of parsing
Using
in the
your
past.
parser,
It was all around
YouTube
parsing
series.
graphics file formats and
I
things
watched
like
this
that.
shit. That's pretty good.
So
These
these are just things that I
It's so
said.
much easier.
Again, this is all around illustrating like where it's
Yeah.
clearly you've already brought up the string stuff, and I think that like
Oh, there's
we can live without the ABNF stuff, but that's a great thing to like have people like trying to write. to come up
Shit.
with.
Oh, it gets even more scary.
Yeah, so the issue is allocating spans cross segment. Yes, that's a whole like adding that the allocator thing, and like well then you use the other one. we don't have the UTF-16 parser, so we can't do UTF-16 unless we actually get that thing up to shape and ship it.
So where would we put these guys? They would just be other extension methods over what exactly?
What, UTF-16 parser?
Yeah.
It would go where UTF-8 parser is.
Oh, so you're not talking about adding extension methods and sequence reader extension, you're talking about the fact that we literally don't have a class called UTF-8.
Oh, yeah.
Yes.
Well, we do, we just didn't ship it, we didn't finish it.
Right,
We
yeah.
have it?
In Cortex Lab.
Internal.
Oh, shit, yeah, with it.
But it needs a fair amount of work.
I
It's
see.
like,
Fun.
the UTF-8 parser was iterated on by somebody who's no longer at the company, done, and like, we'd have to track all the things in the line. It's really, really subtle.
I want
How
string
crazy
overloads
is
first.
this?
I want string overloads before that.
Huh?
Before that. I want the string overloads before the other thing.
Yeah. All right, it's good to know. The parsing must be bounded. That's the thing we talked about. UTF-8 parser is not really.
Should be worried.
Are
Are you guys planning on using this?
So sequence reader can be used inside async methods.
Yep.
And there's
By design.
Yeah, it's by design, but there's a mitigation coming where you can make the statics and stuff. I can call that out.
Uh-huh.
Statistical methods are going to be awesome.
Yeah.
Yeah.
So I'm calling out the pieces. This can't static out without. It's unsafe. I called out, I think, both of them maybe, but like the one was the being able the peak thing could be dealt with because we're not modifying the state of the external struct. So the read only makes this read only. The other ones we just need to say that we're not capturing this, the not capture one. And there's not an issue for that yet. That's just there's a number of other things I'm talking with Jared about that thing's coming with. So, like,
So I don't understand, like, why can't we use the safe ones? Because they don't.
because the current check that C# does is it says, oh, you're calling a method that takes a span, right? And that method is on something that's a ref struct. So that ref object could, in theory,
capture the span. That, yeah, I remember this. Yeah,
so,
oh, it's really
so we need some way to it's a known thing. It's just a matter of when we get it.
So ref structs basically can never accept stack allocated stuff then, effectively.
Well, they can. You just have to reveal it's unsafe.
Yeah, it's because they don't know. They didn't bother, like, well, it's kind of hard to know.
The current proposal was that like we have another attribute that you add, whether we're using an existing name, but like, it would be no capture. So like your in parameter would be no capture.
Oh my god.
Whatever the name is going to be, just don't get caught up on my evil thing. But then
something const.
Yeah.
I don't understand the next one. The sequence reader is large. It says passing by reference is necessary to get the best performance. Isn't it necessary to get functionality because this is a mutable ref struct?
Yeah.
Yeah. Well, if you yes, there's that too. If you're keeping track of state upstream, yes, you have to pass it by ref. If you're not,
so
if your state is only going,
if you're copying these things around, you have bugs.
Yeah.
Yes, I'm just calling it out because like that's there's bad news on both.
We need an attribute. Ref one with.
That came up before about having a way to block passing by copy.
I mean, there are things
I know there are
that
proposals out for
make
that.
things
Yeah.
non-copyable.
This came out like a year ago.
Do not copy.
Doing spans.
Rust does that.
So,
Rest of their-
well, copying here, you do want to copy this in some cases. That's another use scenario of like
So
where
we
you
do
want
we do copy it. So in the current parser, we do copy it because we don't peak sometimes. The code we have
to
to,
keep so you can rewind
to go
basically.
forward. And yeah. So it's
roll
kind
back
of
stuff.
It's the cheap. It's expensive to do though.
Yeah. So it got bigger because we added the allocator.
Yes, but it's already.
I know. Tipping point.
So Ben,
It's literally like over 90 bytes because of the weight, because we have so many objects in it. Like
Yeah.
the objects are forced, so it's worse than a regular.
We did see big perf issues with regards to zeroing out structs that have structs inside of them. And that isn't fixed yet, I don't think. So that may be also a big cost.
and Ben Adams in chat is asking about if there's going to be memory barriers and additional costs for having the delegate be a field rather than a parameter.
Huh.
Because you're going to be paying for the allocator field in the size and the extra copy cost, and it will cause a memory barrier every time you have to read it.
Every time you have to read the field.
Yeah.
I didn't measure any perf changes when I changed to using the default one.
How many things would need it?
Huh?
How many things would need it?
How many things need this? Very few. It doesn't come up often. That's only when you're crossing
So there would
sequences.
only be a few methods that wouldn't have to take a delegate then. Well, maybe that's workable then.
Oh, I see what you're asking.
Yeah.
Right. Yeah, but then you're like, I think the perf hit actually comes in here from actually having to pass an extra argument.
Okay.
Then you'd have to have a default for that, and pass. I guess we can make it a little bit. I did not measure, by the way, any impact
Yeah.
on. I have an artificial thing where I'm parsing or I'm reading out stuff
Mhm.
in like 100,000.
Yeah, I think the concern there
Split
is
on
just-
every 10 to 100 bytes. And,
I think the concern there is just since it's a managed pointer, you have to have the memory barrier to save with the GC in case anything moved. So
okay.
But even if the thing lives on the stack,
And I think it.
No, because nothing can change when it's on the stack.
right?
So-
It can't just understand. Yeah.
I think memory barriers are literally for heap objects, right? There should
well,
not-
with the delegate is a heap object.
The only
no, but
place, the
you're
only
holding
place
on to it
barrier.
from the field, right? Why would you need a barrier on that point?
Yeah, so when you read the field, it has to sync with the actual location.
Right, barriers is the thing that DGC uses.
I think it's the point.
Check for.
Yeah, but the field you're reading
It's not like the actual
is
barrier.
guaranteed to be on the stack, right?
It's not like barrier.
Yeah, the field would be.
Doesn't that change that?
Maybe.
Why would the
I don't
field-
remember all the
Why is the
exact
field on the
rules
stack?
there.
I think so.
Because it's a restaurant,
Oh,
so the field cannot
Let's
be
put it
in.
into
any help that people are willing to
Right
give
now.
on trying to find some of these like hidden gotchas.
Yeah.
Right,
So,
don't-
Alright, thanks, guys, online.
He converted the parser to use the thing.
yeah, let's put it into Kestrel.
So you
New,
measure.
new reader. Like you can even replace the reader by source in Kestrel and
I need